Unit 2, Lesson 5, Packets. In this lesson, or at the conclusion of it, students will be able to describe how information flows through the internet as a data stream of packets. They should be able to explain how a packet numbering and reordering can allow for large messages to reliably be sent, even if packets are dropped or arrive out of order. Students will be able to explain the differences between the Transmission Control Protocol, TCP, and the User Datagram Protocol. So warm-up. Suppose our library is moving to a new building on campus, and the librarian has asked for your help. What approach would you take if you just needed to clear out the space by the end of the day? Period. It's your only objective. Clear it out. Move it. Or how would your approach change if you had more time and you wanted to check that every book made it safely and was on the same shelf it was on before the move? Pause the video and write down what you would do in each one of these situations. Okay, now in class, I would ask for responses. Here, I'm going to discuss the fact that in the first instance, where you had just today to do it, you would probably load books into boxes and simply carry them over. You might even be okay if some were lost or the order of the books got messed up. Whatever, it didn't matter. Speed was what mattered. In the second case, there'd be a need of some kind. There would need to be some kind of record keeping in order to make sure that every book was recorded, and when it left one place, it got to the other place, and it was in the proper order. In both cases, you would not move the entire library at once. You wouldn't take every book and all at once move them all. Instead, you would move boxes, put the books into boxes, and move the boxes or the chunks of books. In the last lesson, we learned that messages can take different paths to get to the same place on the internet. Sometimes we need to send really large messages over the internet, like movies or large pictures. Just like moving your entire school library, there are problems that arise when we want to send large messages on the internet. Today, we are going to look at and learn about two different protocols for sending information online. One that's used when all we care about is speed, and one that's used when accuracy is more important. In this lesson, we're going to learn about these two protocols. One for when speed is important, one for when accuracy is important. Activity. At this time, go to code.org, log in, proceed to Unit 2, Lesson 5, and navigate to Level 2. Right here is our Level 2. You will work with one other partner. If you're doing this and watching this video alone, obviously you won't be able to have the give and take on a network that you would with a partner, but you can see the things that were discovered, the things that were done in class. Now, this is an updated internet simulator. You and your partner will open the internet simulator and join a different router than your partner. So whoever your partner is, if they're on router 1, you're on router 2, 3, or 4, etc. Ask your partner for their IP address. Using only the simulator, have a conversation about one of the following topics: your favorite movie, your favorite band or artist, the one superpower you wish you had. And then try to discover every way the simulator is different than the last time we used it. Give yourself about 5 minutes to do this. And you're back. What changed from the last time we did it? You should have these listed in your notes. In class, I would ask for volunteers. So here's what changed. A single message can be made up of many packets, which you can add with the Add Packet button. Right down here, Add Packet. Packets can only be 80 bits long. 16 bits are already used for packet metadata, data added to help route your messages. This means you only have 64 bits or 8 ASCII characters free for each of your messages. Now, you should have a pen or pencil, some kind of a writing instrument, and your activity guide. The activity guide is available either from code.org or from your Canvas homepage. Either one, you can get a copy of it, and you can have a Word, you can have it in PDF, you can write on it, whatever needs to be done. Now, pause the video here if you still need to go and get your activity guide. Otherwise, let the video roll. Protocol 1, just send the packets. Send a single message that includes 5 to 10 packets to your partner. So go ahead and do that right now. Okay, you've done that? Fantastic. At this point, open the log browser. Filter to your traffic on all routers. Read the traffic and answer the questions in your activity guide. You should take 10 or fewer minutes to do this. Pause the video and go ahead and do this now. All right, responses to those activity guide questions. Again, if this were a synchronous course and you were here with me, I would ask for how you responded. Since it's not, I'm going to go over some basic responses. 1, packets can take different paths or just be dropped, like messages in the previous lesson. That was something very similar. As a result, messages might arrive out of order. The fact that one message is made up of a bunch of packets could come in different orders. While a human might be able to understand the original message based on the context, a computer would not. The message would simply be lost. This protocol is simple and fast, but not very accurate. This is when speed counts. Accuracy is second. There's 2 protocols commonly used to send packets online, and depending on the situation, websites will choose the one that makes sense. What we've just looked at is User Datagram Protocol, or UDP. The main idea here, like Protocol 1, or clearing out the library as fast as you can, the goal is to send information quickly without worrying about accuracy. Basics of how it works? Well, we send all the packets, but don't bother checking to see if they all got through, or even if they arrived in the right order. Uses in real life. When would we do this? Well, useful when split seconds matter, more than correcting errors, like video conferencing, live streaming, and online gaming. Protocol 2. What happens when accuracy is more important, or is more important, and we need to check for errors? Well, Protocol 2, you're going to create a protocol that will solve the problems that you saw in Protocol 1 by doing some error checking. The sender should be able to construct a single multi-packet message that is sent once. Afterwards, they can keep communicating to fix any errors in the transmission. Things to consider. How will the receiver know the order of the packets, or if any are missing? How will the receiver request missing packets, and what will the sender do in response? How will both sender and receiver know the full message arrived successfully? Now, for this, I'm going to break you up, if you're virtual, into breakout rooms. If we're live, I would set you in groups. And if you're watching this on a video all by yourself, you're going to have to do it, well, by yourself. Think about this and write down some details of your protocol. How would it work? Take about 10 minutes. Have you created a protocol? I hope you have. Now, let's have a couple of protocols shared. In class, online, as long as it's synchronous, I would ask you to share out what your protocols were. Then, here are some things that you should have thought about. Each packet is numbered or otherwise indicates which order it should go in, whether you want to use numbers or A, B, C, D. Anything like that would work. Each packet includes the total number of packets, again, perhaps with a number, so the receiver knows how many packets to expect. The receiver requests missing packets or confirms received packets, so the sender knows which to resend. It doesn't matter which way you do that. It has to be one of them. The sender and receiver both know when the message has been successfully received. There could be some kind of an acknowledgement sent that all 20 messages were received. There's two protocols commonly used to send packets online, and depending on the situation, websites will choose the one that makes sense. What we just looked at was Transmission Control Protocol, or TCP. Its main idea is like Protocol 2, or numbering every book in the library. It's slower, but much more accurate. How it works? Well, you number the packets so they can be reordered, and you can confirm that all were received. It's kind of like saying this is 3 of 7 messages. Multiple back and forth confirmations between sender and receiver are performed. Uses in real life? This is when accuracy matters more than saving a split second, like sending emails, photos, or just browsing websites. As a wrap-up, we're going to watch the movie or the video, The Internet, Packets, Routing, and Reliability. This is one that was created by code.org. If you're watching this video, continue to the end of the video and then select this video to watch next from the lesson page in Canvas. Now, as a final wrap-up, here are vocabulary terms and their meanings. We have data stream. It's the information passed through the internet in packets. Packet metadata. Data added to packets to help route them through the network and reassemble the original message. Transmission Control Protocol, TCP. A protocol for sending packets that does error checking to ensure all packets are received and properly ordered. Here's an example here where the IP address of the sender and receiver helps route the message. It says who it's going to, who it's from. A packet is simply a chunk of data sent over a network. Larger messages are divided into packets that may arrive at the destination in order, out of order, or not at all. User Datagram Protocol, UDP. It's a protocol for sending packets quickly with minimal error checking and no resending of dropped packets. These terms you will be responsible for at the end of this unit. Now, the final Unit 2 topic comes up in our next lesson, and that will be DNS and HTTP. If you're watching this lesson as a makeup from being absent in class, please go ahead and watch the video that's also in the Canvas course.